In this video, we are going to look at how to get um, from moles of one substance to moles of a different substance. So if we're asked how many moles of substance B was produced if we used a certain amount of substance A, this is the um, conversion factors set up stoichiometric calculations that you are going to use to figure it out. And so you'll be able to use mole ratios as a conversion factor to convert from moles of A to moles of B. And our first step in doing so is to use our coefficients to find the number of moles. And we're going to use our balanced equation for this. Our equation must be balanced. So if it's not balanced, it will need to be balanced. But because we have 4 NAs on both sides and 2 O's on both sides, it is balanced. So our coefficients are our number of moles, and our coefficients are these numbers up front that I'm highlighting in pink. If there is no number, so like O2 doesn't have a coefficient in front of it, it's just going to be 1. And so our number of moles of Na is 4 moles because we have a 4 as our coefficient in front. Our number of moles of O2 is 1 because we have no number, but then I put a 1 in front of O2. And then our number of moles for Na2O is 2 because we have a 2 as our coefficient in front of Na2O. So your coefficient number from your balanced equation is your number of moles for that molecule. Our second step is to write our mole ratio. So a mole ratio is you're just comparing the number of moles from your balanced equation of one molecule to the other. So if we wanted to write our ratio of moles of Na to moles of O2, we would use our moles of our substance from our first part to help us do so. And so in our balanced equation, for every 4 moles of Na we have 1 mole of O2. And this ratio will always be that. For every 4 moles of Na, I have to have 1 mole of O2. If we were to do moles of Na to moles of Na2O, our ratio would be 4 moles of Na, because that's our coefficient on Na, to 2 moles of Na2O, because that is our coefficient on Na2O. And so when you're doing these problems, you don't have to do every single ratio before you solve it. You really only have to do the one that they're asking for. And so we're going to look at what that looks like. So we can use our mole ratio that we found as our conversion factor. So just like to get from feet to inches, you would do 1 foot equals 12 inches. For us to figure out how many moles that we have, if we have a certain number of moles of the other, we can use our mole ratio because we have to have a specific number for every number of one molecule. So instead of doing all of the mole ratios, we can just use our question to help us figure out what ratio we need instead of writing all of them and then deciding. So our question is, how many moles of Na2O are produced if we have 3 moles of Na reacted? And so our two different molecules that we will be using are Na2O and Na. And so because we are just looking at those two, we are only going to write our ratio with that or those two molecules. And so, like we said earlier, our mole ratio is our coefficient numbers, and we're looking at Na and Na2O. So the mole ratio using our coefficient numbers is 4 moles of Na to 2 moles of Na2O. So if you're wondering where I got the 4 and the 2 from, the 4 moles of Na comes from this 4 in front of Na, and then the 2 moles of Na2O comes from that 2 in front of Na2O. So our ratio that we're always going to have is for every 4 moles of Na, we have to have 2 moles of Na2O. Our next step, once we know our mole ratio, which will be our conversion factor, is we can go ahead and set up this problem to solve. And so let's break down our question. It says how many moles of Na2O were produced if 3 moles of Na were reacted? So our known, the number that they give us to start with to figure out our answer, is 3 moles of Na. That is our known. What they're asking us to find, what our new units are going to be in, is moles of Na2O. That's our new unit because that's what we want. So now we can go ahead and set up our equation. Our standard equation is our known number in front, and then in parentheses we have new units divided by old units. And the reason that the parentheses are blue is because the numbers that go in there are the numbers from our conversion factor, which in this case is our mole ratio. So because we're trying to go from one type of molecule to the other and figure out how many moles of the one given moles of the other, our mole ratio is going to be our conversion factor. Our known number that we found from our question was 3 moles of Na, and then we're going to have our conversion factor, which we said was our mole ratio. And so we know our old units are going to be the same as what we start with. So we know our old units are going to be moles of Na, so we can go ahead and put those on the bottom, and our moles of Na2O are going to be our new units because that is what we are looking for. So new units on top, old units on the bottom. Moles of Na2O on the top because that's what we want, that's what we want our answer to be in. And then moles of Na on the bottom because that's the unit that they give us to start with. So once we know where our new units and our old units are going to go, we can go ahead and put those numbers with. So like I said earlier, our mole ratio is going to be our conversion factor. And so we're going to put those numbers for our mole ratio in those parentheses. Our mole ratio is 4 moles of Na to 2 moles of Na2O. And so we're just going to match the numbers that are with those units with the units in the parentheses. So we have 4 with moles of Na. And so we're going to go ahead and put the 4 with that unit and 2 moles of Na2O. So we're going to put the 2 with that unit. Our last step is to plug this into the calculator exactly like you see it. 3 parentheses, 2 on the top, 4 on the bottom, close it, and our answer is 1.5. So 1.5, and they wanted it in moles of Na2O. So 1.5 moles of Na2O. Now, does this answer make sense? Well, we know that for every 4 moles of Na, we have 2 moles of Na2O. So we have half the amount of Na2O that we will Na. If we started with 3 moles of Na and our answer is 1.5 moles of Na2O, that is half of it. So yes, our answer does make sense. So when you are trying to go from one molecule to another, you have to use your mole ratio, and that's going to help you get from moles of one substance to moles of another. And your mole ratio will be your conversion factor.